Okay, hi, welcome to this presentation covering some Burp Suite techniques which are not discussed much and rarely used, but very powerful techniques in themselves. The first one will be content discovery, and the second one will be the match and replace rules. And the objective of both these techniques is to find additional endpoints, but also previously hidden content and hidden features within web application. And for the purposes of this presentation, we're going to be testing against the National Cyber Security Center website. Now, the reason we can test against the NCSC is because they're part of the HackerOne web bug bounty program. So since I have an account with HackerOne, I'm allowed to legally test National Cybersecurity Center. Of course, any site or application which is not part of a bug bounty program, it's illegal to test them. In terms of the techniques we'll cover, we'll be using obviously Burp Suite, professional version, but the testing within the content discovery and match and replace will focus on the OWASP Top 10, specifically 3 of the top 10. So that'll be injection, specifically SQL injection, security misconfiguration, and cross-site scripting. So as stated, the objective of Burp content discovery is to find more endpoints, because the more endpoints we have, the greater the attack surface and the more probability and likelihood of us finding vulnerabilities in those endpoints. Now, Burp spidering, scanning, as well as manually going through the application with Burp proxy mapping enabled, that does a great job in finding large parts of the application. What content discovery does, and it's a feature found in engagement tools, is that we can find hidden files on content and therefore increase our attack surface. Now, server-side files such as .php or .config, ASP, ASPX, they cannot be downloaded. And the reason is because they are the core source code of the application, and they will contain usernames and passwords, database queries, and configurations. Since they cannot be downloaded, most of this information, this critical information, is not available to us. But what happens is sometimes admins or developers, instead of deleting a file, they will create a backup of it, and they'll rename the extension to .back or .backup, or they'll combine a number of files as a zip file. And since these files are not linked, these backup files, they're not linked. They will remain hidden from Burp Scanner, Burp Proxy, and Burp Spidering. So what the content discovery does, feature of Burp, is it tests for common backup file extensions against known server-side extensions such as .php. By testing those, and if it gets, it'll request those, and if it gets a status 200 back, HTTP is 200 back, then it knows that a file exists, and then often you can view the .back or .backup files and download them and access a previously hidden but critical part of the web application. This is the top 10 version of OWASP as of the 2017 list. Sometimes I feel that overemphasis is given to the top 10 without appreciating that many real vulnerabilities, such as server-side request forgery or API security, or even client-side request forgery, CSRF, are not part of the top 10 anymore. And in terms of SSRF, server-side request forgery, have never been part of the top 10. So Just because a web application is not vulnerable to the top 10 techniques, or a specific tester cannot find any vulnerabilities against the top 10 techniques, it's important for customers to understand that there are other techniques out there over and above the top 10, which should also be tested, which can lead to compromise of the web application. But anyway, in terms of this top 10, we'll be using Burp Suite to test specifically for against injection. So specifically SQL injection in this instance, but injection can also be command injection, but we'll be testing for SQL injection, and we'll also be testing for security misconfiguration, which is the backup files. I would class that as a misconfiguration, and cross-site scripting as well. And we're going to be testing against the UK National Cybersecurity Centre, their main website, ncsc.gov.uk. It's a fairly basic site. It has very few features. Certainly in terms of testing, there's not much there that you can find vulnerable, because there's very little interactivity. The only area of interest, I suppose, would be the content, the contact us forms, and the search. But for most part, the site is very informational. It just gives information and gives reports and things like that. There are other areas of NCSC which are more interesting, but they're hosted on separate subdomains. So things like WebCheck and MailCheck, which I use, they provide lots of features, which are good areas to test from. Now, NCSC is a program as part of the HackerOne bug bounty portal, and this page is important because it lists NCSC and also lists the guidelines from which we can test, and it's important that we comply and we remain within the permitted testing boundaries. I think it's important to note that we can test all subdomains of ncsc.gov.uk. But for the purposes of this test, we'll be just looking at the main www site. As previously stated, that NCSC site, for the most part, is an informational site, and from a bug bounty tester's perspective, there's not much for us to test in terms of features. But it makes a good site for us from a content discovery perspective, because there's bound to be some backup files, which is what we're looking for. But before we start, I think Google Dorking is always a useful place to start. And here we can see that I'm testing for what server-side files exist on the server, but none are found. So it's likely the NCSC are using some URL rewriting tools to keep the server-side technology hidden. Find a text file there on a different subdomain. But just to recap, OWASP Top 10 and the content discovery maps to number 6 of the top 10, that being security misconfigurations. Now, if we go into the Burp application, we can see that large parts of the NCSC site we've already mapped previously using Burp Scanner, Burp Crawl, and manual proxy browsing. So we can see in the sitemap that large parts of the site are already present. In terms of content discovery, so from engagement tools, we click on Discover Content, and from here we will see that there are large parts of the testing which are highly configurable, from the file names to the file extensions. And we can see in terms of the extensions, to test. We can see that .back and BAC and backup are there, and then click on the edit. We can see there are other common formats such as old, or original, save, tar, that maybe are stored on the server. And then we take the default config and we just start the session and see what results start coming back. Now we left the discovery running for a while, and we can see the result of running it is that we have a lot more endpoints now, which the content discovery has found. You can see the size of the sitemap has almost doubled, which is good because, as we originally said, the more endpoints we have, the bigger the attack surface and the more potential vulnerabilities there are. If we look at specifically the results, we can see these are the additional files found, or file endpoints found. And if you organize by status, we can look at some interesting server-side bugs and prioritize. So if you take these HTTP 500 messages, so 500s are server-side error messages, and we can see if this page is accessed, the response is that it gives that the NCSC site is offline, which we know it's not, but that's a standard response given. We can see this is a response in the browser as opposed to Burp. Now, HTTP 403 responses are also interesting, and they are access denied messages, forbidden, and we can see that we get a different error for those. We get a straight out message stating from the most probably a web application firewall saying we're not permitted to view this request, blocked. Now, what I would do for these is for the 403 errors, I would use Jason Haddock's all.txt and do something called force browsing within that directory, and the all.txt will be a great place to load into Intruder, so we can do some fuzzing and see what can be bypassed. So for fuzzing, I always use Intruder. Now, going back to the sitemap, interesting endpoint I found was an API, specifically this part of the API, page URL equals feature. Now, any bug bounty tester, when they see this, they will automatically think of a local file include or a remote file include bug. When we open this link in the browser, we can see we get some type of XML data. And then when we change that source to an external page, we can see it'll come back with an error message. There we go. So well worth testing that via fuzzing to see what else we can find if we can dig deeper. Another interesting thing I found was the handling of null, specifically within the cookie. Here we can see the first request is set to null, and we will get a 403 response for forbidden. But when the follow-up is set to Zul, we can see this time we get a valid 200 response and some page content. So again, well worth spending some time here to figure out what's going on and how it can be exploited. However, Let's not forget the original reason of content discovery was to find backup files. So if we go back and within the issue activity, we can see within this section of APIs, sorry, within the folder of APIs, we can see we find some backup files. So section content.backup gives a 403 forbidden, and also another backup file. But if we move over to the main issues list, we can see that there are quite a few backup files there, which we found within NCSE. So all these ones we should load and investigate and see. Okay, let's move on to the second burp technique, which we want to look at today, which is burp match and replace. And this is a very powerful underused feature. And it's really excellent to use when you're testing some simple error-based SQL injection, or testing for simple error-based SQL injection, as well as some simple cross-site scripting from the user interface directly. And I discovered this technique from this tweet from Cody Brokius. And I found it really interesting, and I tested it on a number of web applications to some good results. And if you look at the bottom of the slide there, we see that what the payload does is it consists of two elements. The first comma will check for simple error-based SQL injection, and the rest will check for simple cross-site scripting. And what you do is you configure the burp match and replace rule to test for this to match and replace your entry into the user interface and replace it with this payload. And it's a very fast way of testing, as will become clear in the demonstration. Now, error-based SQL injection via the comma is the most simplest form of SQL injection out there. Because it's quite simple, you would have thought that most developers would have implemented fixes and it shouldn't be found. But I'm just highlighting this example from HackerOne, which is a bug found on the US Department of Defense website, which was just that. It was a simple error-based SQL injection. And the person who found it provides a description. He links through to his website and it gives a more in-depth description. So still well worth testing for simple error-based, because if it's still applicable to US Department of Defense, you can be sure that it's applicable to other organizations elsewhere. Okay, back to Burp. So this time we're going to be using the proxy element of Burp, and we make sure intercept is set to off, and under options the match and replace configuration and the rules can be found within there. But before we enable it, let's go to the NCSE website and test a simple search within the box we'll be putting the payload into. So just so we know what good looks like, what a valid search looks like. So it's important to see if the search how it's returned within Burp, so we can configure the rule based on that. So we searched for Peter, and that came back with that result. And we go into the history, we can see that the search actually is as part of a GET request within the header. So knowing this information, we can configure our rule as a header-based rule. So we're going to be putting XXX, and we're going to replace it with our payload as previously presented. We move the rule up right to the top. Indeed, it's the only enabled rule, so probably didn't need to do that. Okay, within Burp, we disable the rule, and we're going to just test our entry, which is XXX, again to see what a known good looks like. Before we do that, we mark where we're up to within the HTTP history of proxy. So we can see that XXX in uppercase is a valid search term, but there's no results returned. You can see that that was a query made. There is no edit happening because we disabled the rule and we got a valid HTTP 200 OK response back. Now, if we go back and enable the rule and then again mark it within Burp just for our viewability, and then we do the same search again, we can see we get a different return. The page you're looking for can't be found. And let's look at the status code. We can see that it's a HTTP 403 forbidden. So the web application firewall, which no doubt NCSC have, is doing a good job of blocking our basic attempt. And you can see that the auto modification of the request happened there. So generally speaking, when you're looking for an error-based SQL, you're looking for HTTP 500 responses. So in this case, it's not vulnerable, but what the point is to demonstrate that how rapidly you can just test it. So if you go to an application and you see lots of input boxes, so all you need to do is just put XXX in each and using the match and replace rule, and then you can very quickly see what kind of responses come back. So it's just a rapid way of testing. And not only was this site not vulnerable to simple error-based SQL, we can the second half of the payload, which was cross-site scripting, and we didn't get a response from that. So equally, it's not vulnerable to cross-site scripting. Okay, that's all, and hope you've found it beneficial, covering these two advanced Burp techniques: content discovery and matching and replacing. Thanks.